So now that we've gone full cycle and learned about how minerals start deep inside the earth and wind up on the surface in the soil, which is where we get the minerals for our food, let's go ahead and move on to chapter 9. So chapter 9 is going to be the water cycle. And remember we said before, when we discussed in our introductory chapter, that the hydrosphere, this is all of Earth's water supply. And let's just look at the percentages again. So most of Earth's water is stored in the ocean, 96%. And out of that 96%, the rest of it is fresh water. And this shows you here the remaining fresh water. So for the remaining fresh water, most of the fresh water is stored in ice. That's the biggest chunk here. And then after that, the next largest amount is stored in groundwater. And then you have an even smaller proportion that's stored on the surface of the earth. So most of the surface of the water, most of the fresh water on Earth is stored in ice and glaciers. So let's look at how water is going to cycle throughout the globe. And these are terms that we'll see again when we talk about storms and hurricanes. So the first way, so let's just actually concentrate on this picture here. So as you can see here, there are several ways that water moves around. The first one, let's actually look at here. So you have the ocean and you have the sunlight. So what the sunlight does is the heat from the sunlight heats up the ocean surface and causes that water to evaporate. So that's the first way. So that you can say that the sun kicks off the cycle of the cyclic motion of water around the globe. So it starts it off by evaporation. So the water is heated on the surface of the ocean. It rises, and as it rises, it's going to cool down. And as it cools down, it's going to fall back down as rain or as precipitation. And once it lands on the surface of the earth, there's a few things that can happen. Either it can, if it hits a patch of ground that's solid and the water can't penetrate through, it'll just travel on the surface of the water as runoff, and it'll go back into the ocean. Or if the rain lands on an area of the earth that's porous, the water will infiltrate into the earth and then wind its way back into the ocean. But either way, the water returns back into the ocean, where it can cycle back around again and evaporate. So then let's clarify what we just discussed here. So evaporation then is the main way that water interacts with the atmosphere. The reason why is because, remember, we said this also in the first lesson, that 70% of the Earth's surface is covered in water. So most of the surface is covered in water. And so if this is sunlight here coming in, so this is the sun, most of the heat from the sun is going to interact with water on the Earth's surface. So that's going to cause a lot of evaporation. So we say that evaporation is the main way that the water interacts with the atmosphere. So evaporation actually over the ocean is the main way that water interacts with the atmosphere. Interacts with the atmosphere. So remember what evaporation is. It's just, if this is water here, let me do it a better color. So if this is water here, you have liquid water, and you have the heat from the sunlight coming in. So this is the sun, this is the heat from the sunlight. It's going to turn that water into a gas that's going to go into the atmosphere. So let's look at the other case now. So now, once the water leaves the ocean, or the water molecules leave the ocean, they're going to go up into the air and they're going to become clouds. So let's try to draw that then. So this is the ocean, and the water leaves the ocean, and they're going to form clouds. But the clouds, because the higher you go, the colder it gets. The clouds aren't going to stay formed forever. The water in the clouds is going to fall back down as rain, and that is precipitation. And what happens here then is that once the rain falls down, it can land in low places, but it can also land in high places. And the water that lands in high places, it's going to get, because it's going to be cold in those regions, it'll get trapped as ice. So then precipitation stores water in the form of ice. So precipitation, which is the falling of rain or snow, meaning rain or snow, it stores water in glaciers or in ice. So that water doesn't return to the ocean immediately, it stays there for a long time. So we say that this stores the water in glaciers or in ice. So there's an interesting dynamic here between the raining and the evaporating. So if you notice here in this picture, it rains over the ocean, but if you notice, it evaporates more over the ocean, and it rains less over the ocean. And on land, it's the other way. It actually rains more over land, and it evaporates less over the ocean. So we say that, so this is going to be the relationship. Over land, it's going to rain more, so precipitation is going to be greater than evaporation. And over the ocean, it's the other way, because the ocean is mostly water. So over the ocean, it's going to evaporate more because there's more water. So evaporation is going to be greater than precipitation. So we just discussed the main phases: evaporation over the ocean and precipitation and rain over land. But there's some other ones, and we mentioned them earlier, but I'll say it again. So water can seep into the earth. That's going to be called infiltration, or it can travel on the surface of the earth as runoff. But ultimately, all of the water that leaves the ocean has to come back into the ocean. So I'll draw it like this. So however much water leaves the ocean here, however way it needs to, the same amount of water has to come back here, whether it's by infiltration or runoff. So whatever water leaves here has to enter at this location here. So we say then that the amount of runoff into the ocean is balanced by evaporation from the ocean. So the runoff into the ocean is balanced by the evaporation out of the ocean. Because if it wasn't balanced, then that means that the water level would for example, if there was more runoff than there was evaporation, then that means that the water level will constantly be getting higher and higher and higher, but that is not what happened. and vice versa. If there was more evaporation than runoff, that means that more water would be leaving that's being supplied back, so the water level would eventually dry up. But that's not what happens, because the amount of water that leaves the surface of the ocean is replenished by runoff. There's another phase that we can talk about also. So water also evaporates from the surface of the land, a smaller amount, but it still does. So that we call that evapotranspiration. Pretty much sweating. This is what that means. Transpiration means sweating. So evaporating by sweating. That, plants sweat from their skin, as we do also. So evapotranspiration, and this occurs over land. Evapotranspiration. So this is where water evaporates from land into the atmosphere. So, or just when water evaporates over a land. So next, this is going to be a precursor to the chapter 10, the next chapter that we're going to look at. But sea levels have been rising and falling repeatedly in the past due to natural cycles of climate change. So you can see here, this is about 20,000 years ago. North America and most of Europe was covered in ice. And this is now 90 million years ago, when the globe was ice-free for a while. So the rising and the increasing and decreasing of the amount of ice on the surface of the Earth relates to the amount of the height of sea level. So we'll see that in the next chapter. So, but for now, though, just as an introduction, we'll say that the sea level rise. Sea level has risen and fallen repeatedly, and due to climate change in the past. So sea level has risen and fallen in the past due to natural cycles of climate change.